For Learning Guide 2, we're going to go and do the Chem 30 Chapter 10 review on page 466. And just as an overview, Learning Guide 2 is mostly about addition, substitution, and elimination, reactions, along with identifying alcohols, esters, carboxylic acids, and how combining carboxylic acids and alcohols create an ester. Alcohols have the family of OH attached to the rest of the chain, either in between or at the ends, whereas carboxylic acids can only be located at the end of a chain, since once you have your last carbon, you'll have a double bond of oxygen connected to an OH, which is of a carboxyl group, but combined they form carboxylic acid. So this will be all filled, which means it'd have to be located at the end. So in carboxylic acid, you only have to finish it with oic acid, since it cannot be identified 2, 3, 4 in between. Wherever this is, that starts with number 1 in the chain, and then anything else 2, 3, 4, whatever you have, if it's ethyl, propyl, and butyl. We got so looking at number 3 in the chapter review, the type of chemical reactions that involve breaking a carbon-hydrogen bond and replacing the hydrogen atom with another atom or group of atoms is called. So we're talking about reactions. So we have our addition, substitution, elimination. Additions usually follow the order of some kind of double bond creates plus some kind of either organic halide or just hydrogens, for example. And they will form, so if we were to fill this all out, sorry, I wrote really small, plus H. So we'd have an H2 and H2. Now, in an addition reaction, what we would have is that these would break the double bond, which would just form CH2, CH2, with hydrogens on top or the bottom. But really, this just means CH3, CH3. But you can just see that the hydrogens are replaced here so that the compound doesn't change. However, the double bond breaks and becomes a single, becomes saturated, and gets filled by whatever else is in the reaction. If it's ClH, which would just be CH2, CH2 with a Cl or an H. However, these ideas, sometimes when you have propane or something, you might not know the difference between if it should be here or here. In this situation, the chlorine doesn't really matter because you could just say that it's flipped. However, when you get a long chain, sometimes it changes from 3,4 or 4,3 in your chlorine. So how you would show that is similar with math. So if we were to have and we'd have a double bond in butane, we go and say that plus HCl, and fill in the hydrogens. We can go and say that CH3 still, and then CH, break the bond, CH3. We either have a chlorine here and a hydrogen here, or shown by an addition sign, we have CH3, CH, H, CH, Cl, and CH3. Now, these are two different isomers, or technically the same, because they could just be flipped, but the idea is sometimes we'd have, say, 2-chlorobutane, or we could have 3-chlorobutane. Usually it works with longer chains, and then we'd have. But 3-chlorobutane would be wrong because that would just be flipped. But if we were to add maybe another carbon, so it'd be 2-chloropentane, we could have 3-chloropentane. And these would be isomers of difference, same molecular formula, however, named differently. So we'd have to show that with an addition sign. Substitution reactions are when we bring some kind of saturated bond, so say we go and say propane, plus hydrogen and chloride. In a substitution reaction, we'd have still two products. No, like addition reaction. Addition reactions usually are 2 form 1, because it would be a double bond and adding something, and then we have all single bonds, so it'd change from an alkene to an alkane with this replacing the double bond. So in here we have CH3, CH2, CH3 plus hydrogen and chlorine, which would be hydrogen chloride. And so what would happen is over a long time or a catalyst, we could go and have this substitution reaction. So we would have, say, CH3 instead of doing a chlorine substitution reaction, let's talk about bromine. So if we have propane and add with bromine, in our substitution reaction, what would happen is over time, similar to what happens is when we have an alkane, a saturated compound, when we go and add bromine to this propane, or if it was in liquid form or whatever, over time in an alkane, even though at start when you add bromine, it it would turn the solution yellow. However, if you were to check next day or over time, for some reason, and I'll explain, it becomes clear again. The yellow color seems to disappear. It's like magic, but it's not, because it's science. So what happens is we take this bromine, and in a substitution reaction, over a long period of time, we take propane, we'd add it to bromine, which shows that yellow color. And at first, it would still remain yellow. And the next day, what would happen is we'd have either on the first carbon, the bromine would attach itself to the carbon chain. So after a while, after a long process, the bromine gets attracted to the carbon chain and attaches itself. However, it could also, the bromine, one of them, could attach to the middle bond. So the second carbon inside the chain. And lastly, one of the bromines would attach itself to a hydrogen. Bromine, in this case, is shown as double two bromines because bromine is diatomic, meaning we could write it Br2 or like that in a full structure formula. And so we have the two little isomers here. However, we can't tell which one is which one would likely be a product. That's further university chemistry. However, we know it would be either this or this. And if you've ever taken math classes, addition means or. And so that's kind of the idea here. So we have in organic halides, you change the IDE in the, so bromide or chloride or chlorine, bromine, the I in E, and you change it to ORO. So you'd say it's located at 1 bromo propane plus, so the or, I'll write that here, 2 bromo propane plus hydrogen bromide. Condensation reactions you've already done in the last chapter. That's the idea with you're taking a carbon chain. So let's go and do the propane again. And you're having a complete combustion. So condensation is the same thing as kind of saying combustion. So you're saying plus O2, because any kind of combustion, you have to have oxygen. Without oxygen, you can't create a fire. And so propane plus oxygen creates CO2 plus H2O if it was a complete combustion. We'd realize there are 3 carbons here, so we'd have place 3, which makes the oxygen level become 6. We can write that on top. We have 3, 6, 8 hydrogens. So if we already have a 2 here, we need 4. Because 4 times 2 would be 8. Leaving us with 4 oxygens. So 4 plus 6 is equal to 10. So we'd have to write something times 2 to equal 10, and we know that'd be 5. So there'd be 1 here, 5, 3, and 4. And that's just writing out your reaction. So even for the top here, we go and place a 2, 1, 1, 1, and 1. Since there's 2 possible products, we'd have to put a 2 for substitution reactions. In addition reactions, however, you can leave as is. So 1 and 1. Lastly, esterification, we'll worry about that later, but elimination reactions, there can be 2 types of elimination reactions, and they follow this kind of general formula. So we got an alcohol can react with some kind of catalyst, or over time will form alkenes plus water. So an example of that, we could go and say CH3CH with a hydroxide ion with CH3. So this would be named propane 2-ol, since kind of like alkene and alkane and alkyl, we represent the double bond as at the end of the chain. We do that the same thing for alcohols, so wherever the OH is placed, we'll place it at the end and say that it's propane 2-ol. And then this would form alkenes, so we could replace this OH by saying CH2, CH, and CH3, and we place the double bond here and form water, HOH. And then we'd also have an isomer, because who's to say that it's not over here? However, it's the same thing in this situation, because it's propane. However, if it was butane, it might become butene 2 or butane 1. So this would just be simply propene. And because this situation, it really doesn't matter if it's here or here, we'd only have to say propene, or we could say prop 1-ene plus water. But the idea is that, say if it was butane, so if we had CH, if we were to do this all over and we're to say it's CH3, CHOH, CH2, CH3 forms water, HOH. And we could go and say that there's 2 products. Either it'd be located at the front, double bond, CH, CH2, CH3, or an addition would be CH2, CH3, CH and CH3. So what happens is one of the hydrogen gets taken off for a double bond and gets formed to water, and from the OH group off the alcohol, it goes in to become water. So the O gets placed here, and the hydrogen still gets placed there. So the O and the H go here, and is replaced by taking either hydrogen off the second carbon or off the first carbon, wherever it's placed. So we'd have two possible isomers for this one if we were to say the butane 2-ol, because it's placed on the second, we'd say forms water plus, this would be but 1-ene, and this one would be so plus but 2-ene. Because who's to say it'd be here or here? It wouldn't be, it could be over here if it was just flipped, but thinking that it's the same way. We got that. The other elimination reaction, just flipping the page, focus it. Reaction number 2 would be if you were to take an organic halide plus an hydroxide ion would form alkenes, an alkene plus a halide ion plus water. So an example of that would be number 1. Organic halide, we could just go and say, like, let's go in but, so some kind of but chain. Let's go and place it on the second. So we'd go, say, bromine, CH3, CH2, and CH3, plus an OH, a halide ion, to form an alkene. So we'd have two different isomers of alkenes. We could go and say it'd be placed at the front, so CH2, CH2, CH3, and saying that the double bond is on the first, or shown by that plus sign, we'd have it on the second, so it'd be CH3, CH, double bond, CH2, CH3. So these would be but 1-ene plus or but 2-ene, both isomers having the same molecular formula, however have a different molecular structure. Our last two products would be water, so that's HOH, and our last one would be the bromine by itself with a little negative sign for showing that it's an ion. So what happens here is the OH here forms with one of the hydrogens from the double bond and forms water, H2O. The bromine gets eliminated by itself. That's kind of the idea of the elimination reaction. And so we have a double bond, an alkene, a halide ion, which is the bromine, plus water. So we can finally look at number 3 once we've kind of had our overview of what's going on in this chapter. Number 3 says the type of chemical reaction that involves breaking a carbon-hydrogen bond and replacing the hydrogen atom with another atom or group of atoms is called